Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and this week in the news we have the city of Wuppertal. The city of Wuppertal, they had a massive server failure. It's the following article here from Golem. And what caught my attention were two things. Well, first, they still don't know what the issue was, and this is a reminder that distributed systems are complex, especially in the size with 1,000 servers. And I personally would feel uncomfortable bringing those servers back, especially since the reason of this failure is unknown. So they might run, but it may happen again. And the second thing that caught my attention is they have a massive amount of servers in their data centers, 1,000 servers. And I checked the city of Wuppertal, they have more than 350,000 citizens, and that means roughly one server per 350 citizens, and that's quite a lot. And if we compare apple to oranges, I know we should not do that because those servers, those 1,000 servers may be used for remote desktop solutions. However, let's do it anyway. I mentioned in the lecture that Let's Encrypt, they use one server for 230 million certificates that they serve, and they have one massive server serving all those certificates. And we see on the other hand the city of Wuppertal, they have 1,000 servers, but we're not looking into tasks, we're not looking what they're doing. Maybe the servers of Let's Encrypt, they're highly specialized, and the servers from the city of Wuppertal, they're doing something completely different, like remote desktop solutions. They have maybe for their employees a remote desktop where they can work on, but still I think 1,000 servers is quite a lot. And with respect to Let's Encrypt, also in the lecture we looked at the statistics of Let's Encrypt. There I saw some numbers where it indicates that the numbers might not be correct, and I asked them if there is a problem, and they acknowledge that they have a problem, and it's about the data pipeline who seems not to be working, and they are working on a fix. So that means we can see some statistics, and I was referring to the following graph. It's in this site here, statistics, and here we saw this drop. I mentioned this in the lecture, and this seems to be a data pipeline issue. So that was the update on that. The next article shows how powerful hardware is these days. Well, not quite, since the authors used a consumer-grade laptop with Wi-Fi. It's the following article here. So it's a laptop from 2013. It has 8 gigabytes of RAM, and the author managed to have 1 million active WebSockets open on this old machine. And what he had to do is he had to first increase the file limits to roughly 1 million. This can be checked with the Linux command ulimit, and I also mentioned in the news section about the 50 essential Linux commands, about these ones here. Well, turns out ulimit is not on the list, so probably they should create a new blog with the title 51 essential Linux commands that you should know. And the author, he used WebSocket.js, which is a very efficient implementation. It's this one here, and it's faster, 10 times faster than socket IO. So it's quite impressive. And with 50 IP addresses, which had around 20,000 ports assigned. So in total, he had 1 million connection, and he could keep those connections open with WebSocket and on this very old machine. It took him a few minutes to reach this, but nevertheless, after a minute, he had around 995 live WebSocket connections over Wi-Fi, because he was reaching the Wi-Fi limits, and when he used cable, he could easily run this million WebSockets. So in 2013, that was quite fast. So hardware was quite fast then, and nowadays hardware is actually incredibly fast. The next article is about infinite storage. It's the following GitHub repo here, and it's about storing data in video that you can upload to YouTube. And I reported in the last week in the news section that user caused an endless loop, and he had to pay for his mistakes, I mean cash. And here on YouTube, you basically get the resources for free. This is not new. However, what caught my attention was the following comment here. And this GitHub handle here looks familiar. So I scheduled a call with Gil. And Gil, thanks for joining. And could you tell us a bit about how to get infinite storage for free?
Yeah, that's a good question. Well, in the end, everything that is stored is just a sequence of bytes stored physically in disk somewhere. So someone has to store and to persist this data, right? So if you send a file to YouTube, a video to YouTube, there is a data validation that happens in their backend to check if the video that file format is accepted to be stored, persisted in their disks, let's say in their data center. And if you bypass this data validation, this kind of say this wall, which are implementing their backends, you could basically store anything that you want. There's different techniques on how you can do this. For example, you if you want to store like a PDF in YouTube, it's possible, but then you have to transform the PDF into video. There are certain techniques that you can do. For example, transform to QR code, as this project has they have done, or for example, transform the PDF, the sequence of bytes, as images, or transcode into MP4. There's different ways to do that. And then in the end, by passing that, you can store as much data as you want. Of course, that you have like to manage and to keep track. I mean, which data you stored where, but then in the end, you can use even multiple cloud providers, like not only YouTube or not only Google, to encode this PDF and to store it. You can have like a way more, a way broader network to store it. So, and then in the end, to answer your question, you can achieve infinite storage, because in the end, I mean, it's just data. You're persisting data somewhere encoded.
Yeah, it's data validation that is not being validated. And do you know any other services that have these flaws, or kind of this feature?
Yeah, so back in 2013, when I conducted research on data validation in cloud providers, um, there were multiple services that had what I call a weak data validation. From Twitter, to Google, YouTube, and back in the days, the Google Photos was called Google Picasa. Also, for example, SoundCloud also is another provider that allowed, and I think like nowadays it still allows that you persist like that you inject data inside a MP3, for example, and then you can send to SoundCloud, and then they will make it available, to users. So there are multiple. I would say that most cloud providers that are researched in 2013, they should still be vulnerable. Of course, that
Mhm.
validation must be conducted, to 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 properly to confirm this assumption, let's say. But I expect that most. So just to finalize, so besides Google, YouTube, uh, Google Photos, SoundCloud, Twitter, and certainly there are others.
Yeah,
Um,
just opened the PDF from 2013 that you wrote, and there's a list, image check, imager, and so you tested quite so many services.
yeah,
And yeah, if they still have this problem, you can use them and get free storage. That's cool.
absolutely.
Cool.
And just one more thing, Thomas.
Mhm.
These days, for example, Twitter allowed with the blue mark, then now you can buy this badge, which is the blue check. And with the blue check, you can store not only these 250 characters, but way more characters in a single tweet. So basically, what Twitter is doing is that they are also charging for not only for storage, because there are other services, that would cover the cost of this $8, but they're basically opening the attack surface if they have a weak validation. So imagine if you could generate many tweets with a larger text in each tweet that is widely publicly accessible without any authentication. So you could, I would say, I would think that you could build a service like this project of this guy, this infinite storage glitch, and build a file system on top of Twitter Twitter tweets, the blue mark, the blue badge. Yeah, it's quite interesting.
Cool. Thanks. Thanks for the explanation and thanks for taking the time.
Thank you. Cheers, Thomas.
A couple of days ago, the last fully working undersea cable connecting Vietnam broke down. This is the following article here. It's the SMW cable, the CME-V3 cable, and this can be seen on this submarine cable map here. So if we zoom out, we see the green one. This is the CME-V cable connecting here Vietnam, and we see Vietnam is having other connections as well. However, the other undersea cables, they are also damaged or only partially working. And a very interesting statement is that this will not have great impact on the speed of internet connection between the country and the world. And that means so that Vietnam is not only connected or relying on undersea cables, they have land routes as well. And obviously in Switzerland we do have this as well. Here is a reminder of how educational institutions are connected. They are connected via switch, and here we see the connections, and here we have Ost. Ost, if you're wondering, this is this nice building here in the background. So they are connecting via Art Goldau to Zurich, and they also have a connection to Sargans. Another reminder, latency matters. I came across this interesting report from last year. It's the following report here. and the report mentions that there is a 20 millisecond additional latency and the way how he figured it out. So he had this testing setup, he had some input, this is a camera, and whenever the camera sees there's an input, then the time is measured, and he did a really nice analysis, and here we see the typical latency of VS Code. It's around 20 to 30 milliseconds, and then here he tested virtual terminal library applications, and he observed that they added 20 millisecond latency. And this is a reminder that not only hardware may add to latency, but also software. And if we look at also the keyboard input, I have the following keyboard here, which is a Lenovo keyboard. This is connected via USB, and USB does polling. So my computer asks my keyboard, hey, do you have any keys I need to process? And this is done in a regular interval, and the interval adds roughly 10 milliseconds of latency if I press a key until the machine registers that, and this can also be checked here that this is really the case. So we have here our Lenovo ThinkPad compact keyboard, and if we search for interval, we see interval is around 10 milliseconds. There are better keyboards where the polling interval is down at 1 milliseconds. But actually, if you're a gamer and really you worry about latency, then you probably should switch to PS2, because there you don't have any latency, so there's no polling. So the PS2 keyboard sends the key command directly to the machine, so eliminating this latency. The last article is an update on the Swiss bank that is involved in cashing out money from Terra Luna, from Do Kwon. I mentioned that I'm not sure what the Swiss or which financial institution this is, and I also got hints from students that sent me an email. Thanks a lot for that. Currently there are only rumors, and I don't want to spread rumors, but this article from NZZ did actually a fantastic job. It's this article here. I have it in a PDF form since it's behind a paywall. Here in this article, they only mention one Swiss bank. It's Signum, and they ask Signum, can they say anything about that, and they said they cannot confirm or deny. So the name is out there. There are rumors. It might be Signum, but those are just rumors.